This is King of Review. Here we have 3 logs we need to simplify. Now it would be nice if we could combine all 3 of them together, and there are properties of logs that let us combine added and subtracted logs together, but a problem with doing that is that there's a 2 in front of 2 of these logs. So we need to use a property of logs first that says if you have some number a times the log base b of x, we can move the a inside the log, turning it into the log base b of x to the power a. I'm going to apply that to the second and third log in this problem so that we can get these 2's inside the logs. The second log now becomes the log base 3 of 6 squared, moving the 2 inside the log as an exponent. And the last log, by the same logic, becomes the log base 9 of the square root of 36 squared. Now we can simplify pretty easily by changing 6 squared into 36, and the square root of 36 squared is just 36. Now we can almost combine all 3 of these logs together, but the problem we see now is that the third log has a different base than the other 2. But there's a helpful relationship that we know. 3 squared is equal to 9. The first 2 logs have a base of 3, the third one has a base of 9. And there's a property of logs that says if you have some base b squared of x squared in a log, that's the same thing as the log of just base b of just x. We can take the square root of the base and the number inside the log at the same time. If we apply that property to our third log, we can take the square root of 9, the base, and get a base of 3, and take the square root of 36 and get 6. And now we have what we wanted, 3 logs all with a base of 3. So, to combine logs that are added and subtracted, we need 2 properties. The first one says that if we have the log base b of x plus the log base b of y, we can combine those into the log base b of the product x times y. The similar but opposite principle says that if we have subtraction, log base b of x minus log base b of y, that can be combined into the log base b of the quotient x divided by y. So, using both of those properties together here, log base 3 of 2 and log base 3 of 6 are positive, so those will be multiplied. Log base 3 of 36 is the one that's subtracted, so that will be divided. So, in sum, these 3 logs combine into the log base 3 of 2 times 6 divided by 36, which, if we simplify it, becomes the log base 3 of 12 divided by 36, which simplifies further to the log base 3 of 1/3. Now we're almost done. We have a 3 inside the log and a 3 as the base, but the 3 inside the log is a fraction. So let's use the fact that if we give a number an exponent of -1, that's the same thing as taking the reciprocal of that number. 3 to the -1 is equal to 1/3. Now, if we think about the definition of a log, we know that in general, if the log base b of some number a is equal to some number c, that's the same thing as saying b to the c power is equal to a. So, let's set the log we're trying to find equal to x. Using this property on the right, we can rewrite this as 3 to the x equals 3 to the -1. Since we have 3 on both sides, the exponents must match as well, and x, our log, must be -1. So that's what this whole expression simplifies down to. So that's it. Thanks for watching.